Hello everyone, my name is Liheng, and I'm happy to share my experience with the Africa Biomass Challenge. I joined the challenge because it's very closely related to my background and my current work. I got my PhD in the field of environment remote sensing, and I'm working for the Ant Group. It is the largest fintech company in China, and it is often known as the host of Ant Forest, which has planted almost 500 million trees in the past decade. Another reason for me to join the data competition is that it is a great opportunity to learn about people's current work in Africa to promote sustainable agroforestry and increase carbon stock. It is the first time I get to know how cocoa is planted in Ivory Coast. When inspecting the satellite images, I feel it is almost impossible to identify cocoa plantation even at 1 meter high resolution. It is much more difficult to monitor cocoa in Africa than some of my previous work, for example, monitoring palm and rubber plantations in Southeast Asia. As a result, the studies of global change and deforestation become so challenging even when we start considering Africa. One of the most difficult parts in this data competition is that the cloud cover of the test images is so high, much higher than the training set. About 40% of the test samples were totally covered by cloud. I understand because selecting clear images in tropical Africa is really hard. As most of the Sentinel-2 bands have very limited capability of penetrating through clouds, the biomass of the cloud-covered samples is unlikely to be reflected by the image observations. So I split the test set into a clear group and a cloudy group according to the brightness of the optical bands and the thin classification layer with Sentinel-2. During the inference stage, the results for the clear group were directly from the model prediction, and the results for the cloudy group were estimated using the relationship between biomass and canopy height. I divided the entire test area into 5 regions based on the geolocations, as indicated by this map. In each region, a linear regression model between biomass and the canopy height was built using the predictions of the clear samples in the region, which were then used to make estimates for the cloudy samples. The model was assumed to be linear because there are only a small number of samples available. So I think how to deal with cloud is a key component in my method. Just because what we can do with optical images like Sentinel-2 for biomass estimation is really limited. In the future, I hope there could be more data analysis opportunities for LiDAR or SAR. We can make good estimates of tree heights using LiDAR, and we can have indicators like vegetation optical depth from SAR observations. I know the organizer might be planning the next data computation, which is exciting. If possible, I would like to see a training set consisting of 3 types of data: LiDAR, SAR, and field measurements. That will give us the chance to discover the connection between biomass and additional types of remote sensing observations, and further contribute our skills on data science to sustainable development in Africa. Lastly, I would like to say to the organizer, your efforts have brought together a diverse group of people to work on this challenging issue. Thank you for making this data computation possible.